Hello everyone, I am
Exactly.
Shivansh. Today I am going to talk about sorting by count using comparison approach. So first of all, we'll look at the applications of sorting by count. It can be used to sort out trending topic on platforms using sort hashtags and topics by the number of mentions to display what's trending right now. It's also used in finding product popularity on e-commerce websites, like the product with highest ratings or highest number of reviews is placed on the top in comparison to the one with low number of reviews. It is also used in text analysis of large documents, like if we need to find out the frequency of the words in a particular document, then we can use this method. So now we'll understand this question using a problem statement. Let's say we are given an array of size n, which has the elements a1, a2, a3 up to an. And now we have to arrange them in ascending order. Then we use this approach of sorting by count. Basically, in this approach, we compare each element with each other and rank these elements. Suppose we compare an element A and B. If the element B is greater than element A, then the rank of element B will increase by 1 and the rank of element A will remain intact. Same goes vice versa. Um, um, let's say we have given input of 4 to 7 to 5, and then we'll get output of 2 to 4, 5, 7. It is just an example. So I'll explain it to you with a real life analogy. Imagine you are organizing a students in a classroom based on their heights. So you ask all the students to be arranged from shortest to tallest. So how you will approach this? Like suppose you pick up a student, you compare it with a student of any other student. If the height is small, if its height is smaller, then you put the student in front of that student. Otherwise, you put it at the back of that student. Similarly, you do it for all the students, and you keep on doing until all of them are arranged from shortest to largest height, or in other words, in ascending order. Now we'll look at the algorithm of this approach of this method. In this, we are given three inputs. One is array of items. The second is number of items that we have to sort. And other one, we get an output is S, which is a sorted array. So first of all, we'll initialize the count array. Um, So basically, we have created a count array ci. We are running it I loop from 0 to n minus 1, and we are just initializing all the elements to 0 in it. You can see the image clearly where all the elements of the count array are initialized to 0. The second one is the basically the main algorithm of this. In this, we run two for loops. One is I from 0 to n minus 2. Another one is j from 0 from I plus 1 to n minus 1. Then we compare uh, elements in AI, like a ith element to a jth element. If a ith is smaller than aj, then we increase the count array of jth element by 1. Otherwise, we increase the uh, ith element in the count array by 1, like I explained it earlier. So basically, we compare the element if the one with larger is given higher rank. Okay, so as you can see in the diagram I've showed just on the right side, like initially all the elements in the count array are 0. Then as the for zeroth iteration of I passes, then we compare 62 with all the elements. So here we have compared 62 with 31. Since 62 is larger, we are, increase it by 1. Sorry, I'll just go back. Yeah. So since 62 is larger, we increase the 62 by 1. Now we compare it with 84. Since 84 is larger, so we increase 84 by 1. Now we compare it with 96. Now, similarly, so 96 is larger, so we increase it by 1. The remaining two elements, 19 and 47, 62 is larger than both of them, so we increase it by 2. So the final value of 62 in the count array, like the basically the rank of it is third, the 84th is 1 and 96 is 1, and rest others are 0. Now as the second iteration passes, um, and the I value is 1, so we compare 31 with the elements in on the right of it. So as we compare 31 with 84, it is smaller. So 84 we increase it by 1, it becomes 2. Now similarly it goes for 96. So 96 also increases by 1. So its ranks becomes 2. For 19 and 47, 19 it is smaller. So the 31 will increase by 1, and for 47, 47th rank is increased by 1. Similarly, we do it for I is equal to 2. We compare 84 with 96, 19, and 47. As we do so, with when it is compared with 96, 96 rank will be increased, and in the case of 19 and 47, 84th rank will be increased. So the final rank of 84 is found to be fourth. Now, as the third iteration passes, uh, we compare 96 with 19 and 47, and in both of the cases we add 1 to the 90 and the uh, index of the 96th element. And after the last iteration, as we compare 19 and 47, since 47 is larger, we increase it by 1. So the final state of count array, we basically take the diagonal elements, like as I've shown, like I've arranged the diagonal elements, and after it is compared with all of its right elements, it is not increased further. So yeah, we take out all the diagonal elements and we put it in the final state of the count array as shown here. Like here the final state of the count array is 314502. Now we build a sorted array S. What do we do exactly? Here in the algorithm, I've taken the sorted array as to be B rather than S. Okay, so yeah, start a for loop from I is equal to 0 to n minus 1. And for C ith, like the count array, for the count array, the ith index of count array, we take it as the input for the index in the temporary array B. Like we are going to give it as output. And we put array I value in it. Okay, so yeah, we do it. So here is the implementation of counting sorting by count. So first we have start did a for loop, and initially we have created a count array and of size 100, and we initialized all of it to 0. Next we have started two for loops, and if the ith is smaller than aj, then we increased count j element, otherwise we increased count I element. Then we start another for loop, and if in another array b we put to count I element to be ai element. Basically we take as input the, like we tamper the index of bth array as the rank of the element, and on that rank we put the element from the ai, like a array, like the one which we are given as input. And in the main function we have simply created a sample array and temporary array, like the one which we are giving to as output. The n is equal to 6, and we have called out comparison count sort. Then we have started a for loop and printed all the elements in bi and then return 0. So here you can see the output of the array. So now let's talk about the time and space complexity of it. Since they are, as you have seen here, like the two for loops are going on from I is equal to 0 to n, and one is j is equal to I plus 1 to n. You can also see it in the algorithm where I'll show you. Yeah. So I is equal to 0 to n minus 2, and another one is I plus 1 to n minus 1. So yeah, its time complexity we can directly predict to be n square, but if we derive it, you can see from j is going from I plus 1 to n minus 1, and and above which I is going from I is equal to 0 to n minus 2, and inside that there are constant number of iterations. So we pass it 1. After the first summation after the first summation, the output comes out to be n summation of I is equal to 0 to n minus 2 n minus 1 minus I. After doing the last summation, we get it n times n minus 1 by 2, which can be simplified to O n square. The space complexity, we can define it as like we have created another array bn, or the sorry, the count array we have created, which is an additional space. Like you can see here, we have created a count array and we initialized all of it to 0, all of the elements of it to 0. So yeah, so we have created an extra array of size n, so the space complexity is constant for size n, so it is on, big O of n. Now there is another method to perform sorting by count, which is distribution count sort. So basically, distribution count sort is a specialized type of sorting of list of items where the keys come from a known limited number of ranges. This method ensures that the input array is not overwritten and sorts the element by counting the occurrences and by using a distribution array and place them in correct positions in the new array. So basically, by counting the number of occurrences of the particular element in an array, it arranges them in a distribution array, and from that distribution array, it takes the correct positions into a new array. So yeah, it is better than the comparisons approach because it has a time complexity of O(n), big O of n, but in comparison sort, it has a big O of n square. So yeah, it is much more efficient. The space complexity is same in both of them. So yeah, that is all about the count sorting by count. Thank you.